physics teacher is pretty dictatorial about using the proper units, and I am too, but you just have to put it on at the end. So anybody know what the units on this acceleration is going to be? Meters per second squared. Yeah. Yeah, you just got a deal. Just got a deal. It is. Go with it. Have you taken physics? Okay, we'll have to chat about it more later, okay? It is. Go with it. It's going to be the distance over the time squared. Just remember that, biggie, okay? Part B of this asks, so we did this, good. Graph position, velocity, and acceleration all on the same graph for time from 0 to 5. So what should you use if you're going to graph this? I'm going to simplify this as much as I can. What does speeding up mean? What's the simplest way to say it? Velocity and acceleration have what? Yeah, what's an easier way to say the same sign? So velocity and acceleration are both positive or both things. So the green one here, what is the green here? This is the acceleration right here. So let's take a look at this. We know this right here is the acceleration, and it is negative from -2 to the left. Which one's the velocity here? The red one is, correct? So we're looking, when do they have the same sign? To right there. Oh, nope, I did that wrong, right? They should be both negative. So where are they both negative? Both v of t and a of t. So both v of t is less than 0 and a of t is less than 0 where? When t is between what and what? Between what? Say it louder. You got it.
I think
Yeah, it's 1 and 2. It's 1 and 2. Absolutely. Now they're both negative. Where are they both positive? Where does it look like they're both positive? It looks like they're both positive. V of t is greater than 0 and a of t is greater than 0 when what? T is greater than 3. So to answer this question, where is it speeding up? Speeding up when what? When t is between 1 and 2 and when t is greater than what? How can we mathematically check that? Well, we can actually do the analysis up here. Take a look at these. We're looking at the velocity. Can you factor velocity right there? What can you factor out of 16? What can you factor out of 3t? What does this factor into? 3 times? You know what? I'm going to paste this down below. This right here, we can actually check this. Would these be considered clean answers? The numbers 1, 2, and 3? Yes. Does it get much cleaner than that? No. There's no fractions. It's nice. So when you see clean answers like that, that is a strong suggestion that you could do this algebraically. If we had to use our calculators to find some weird decimal, you might still be able to do it algebraically, but it might be a little challenging. This should be pretty straightforward. Let's factor this. 3 times what? Yeah. So this is 4t plus what? So what does that factor in? 3 times what? T minus what? 1, and you said the other one? T minus 3. And what does this one factor into? 3 times 6. Yeah, good job. 6 times what? T minus 2. So this automatically tells us this is where that 2 comes from. We know that to the left, it's going to be negative, and to the right of 2, it's going to be positive. And what are the other breakpoints right here? It hits when t is 1 and t is 2. So does that match what we just got? Yeah, we graphically saw it, and it's a little easier to see this way. Absolutely. Again, the trickiest part of this was finding the appropriate what? Find the appropriate. So anytime you graph something, you're like, I don't see it. Always remember, where's Fan? Where's she? Where is she? Okay. Okay, here we go. Let's pause. Yeah, I wrote it. I simplified. I mean, it's debatable which one's like more simple, but because this isn't a quotient, what are we not going to use? We're not going to use the quotient rule. So let's take the first derivative. What's the first derivative, Neil? Neil? I like negative 1 times x to the what? I like that. Leave it as negative 1. What does y second derivative equal? Well, the negative 1 is still there. What do I drop to the front? 2. Now it's x to the what? 3. Let's do a couple more. So instead of doing y triple, I'm just going to do y. The third derivative is going to be negative 1 times x to the what? Now, could I multiply out those negative 1, 2, and 3's? Why am I not multiplying it out?
Let's change.
I'm looking for a pattern. So I'm gonna. What's the next thing that's going to drop down? 4, the negative 5. What's that called?
I don't know what's called. Factorial.
You use an exclamation point, and it's called a factorial. Exactly. So let's look at this. This is the third derivative, and what is the power? It's negative 4. When it was the second derivative, it was negative 3. So here's what you then try to do. What is the nth derivative? N factorial, I agree, times x to the what power? Negative n plus 1. There's one thing that we haven't accounted for yet. What kinds of numbers do we keep on repeatedly dropping to the front? Negative numbers. What's a negative times a negative? Times a negative? Times a negative? What's happening to the sign? So this one right here is negative. This one right here is positive. This is, so it flips between negative, positive, negative. Keep looking at this. You have first power is negative. Second power is positive. Third derivative is, so what do you notice? What's the relationship here? What number derivative is going to be negative? Odds are going to be negative. Odds. So how do you get something to flip between positive and negative? Multiply by what? Negative 1. So we need to add in times negative 1, but we have to be careful. What do we have to do? That negative 1 needs to flip, right? Depending on if the power is even or... If the power is odd, we want it to be... Negative n. Not negative n, sorry, just n. What's negative 1 to the first power? It's negative 1 to the second power. Ah, what's negative 1 to the fourth power? 1. Negative 1 to the sixth power? Negative 1 to an even power is always... Negative 1 to an odd power is always... This is really common. If you need something to flip signs, it's negative 1 times maybe n or n plus 1, depending on if you need to be positive, even, or odd. So if we plug this in, what would be the 10th derivative of this? The 10th derivative would be negative 1 to the times 10 factorial times x to the negative what? Yeah, 10 plus 1, then negative.
Why is it negative 10 plus 1?
Because it's the opposite. Look, 3 corresponded to negative 4. Remember, you subtract 1 from the power every time you drop it down? Yeah. So I'm just saying, what's the 10th derivative of this 1? So what is negative 1 to the 10th power? 1. So this is just 10 factorial times x to the... And you might see it written as 10 factorial over x to the 11. That's the same thing. It's debatable which one is more simple. Question for you. Why am I leaving it as 10 factorial? It's huge. If you write 10 factorial, I will recognize 10 with the exclamation point as being correct. 10 factorial, how many digits is 10 factorial? Can you tell me? Kids, on your calculator, do you find it where factorial is?